Okay guys, it's Mr. Riz, and we're going to continue the last section of 1.3, and we're going to be dividing out rationalization techniques. Basically, we'll be going through and figuring out how to get square roots. Now, just like before, what we're going to be doing is I'll show you an example, and then at the very end, we'll work out a problem. So one procedure for finding a limit analytically is dividing out technique. This technique divides out a common factor. So what we can do here is, say we have the limit as x goes to -3. Now we know if we plug in -3, and here we'd get a 0 on the bottom, which wouldn't work. So what we can do is factor out the top to x squared plus x minus 6, and we can factor that out. We get a factor of x plus 3 and x minus 2. Now since there's an x plus 3 on the top and from the bottom, we can just simplify to x minus 2. And now we can plug in our -3. So let's kind of review what we just did in the last section. What gets a little bit more difficult is next. Oh, here's it visually. Now say we have a square root on the top, and we really can't factor anything out of an x. Another way we can do is rationalizing technique. And if you guys remember, rationalizing a square root is when we multiply it by a fancy looking 1. Or in this case, we're going to multiply it by radical x minus 4 over radical x minus 4. This is the fancy 1. And you'll have to remember, we're going to have to FOIL this part. A lot of people forget to do that. So we're going to rationalize at the top here, and no matter what our radical is, we're going to leave the radical the same. We're just going to basically change the term. So in this problem here, we have radical x plus 1 minus 1. So we're going to do radical x plus 1 plus 1. All we did was change the minus sign to plus. Now when we FOIL these terms, first we're going to basically have the square roots cancel out, so we get x plus 1, and then the terms are going to cancel each other out, the outer and the inner, because we're going to have a negative and we're going to have a positive, and then we're just going to get a minus the last term squared, which in this case is 1. Then we simplify, that just becomes x, and the bottom, what we're basically going to do, and the technique is just to do, okay, that times that. So we have x times that. The x's cancel out. So an equivalent equation would be 1 over radical x plus 1 plus 1. Now what we can do is just use our direct substitution and plug in 0 in for the x's. And what we get, 1 over 1 plus 1, which equals 1/2. You can see on the graph, this is our original equation. Notice that there, right at 0, there's a discontinuous spot because 0 cannot be on the denominator. And we can always double check using the graphing calculator, making a table and getting closer and closer to 0. Negative 0.001 is 0.5001. We can see we're getting very close to 0.5, which is 1/2. Now let's go through another one, and we'll just work out the steps here. So I have the limit as x approaches 4 of radical x plus 5 minus 3 over x minus 4. We need to rationalize this, and also we can't use direct substitution. We should always double check that, because when we plug 4 into the denominator, it doesn't work. We're going to have to multiply by radical x plus 5 plus 3 over radical x plus 5 plus 3. Now the top, basically we're going to take this and square it, or get rid of the square root, so we get x plus 5 on the top, minus, then we need to square that term, so minus 9. The inner terms of the FOIL, the o and the I, cancel each other out. Now the bottom terms, we're just going to put that times that, so x minus 4 times radical x plus 5 plus 3. Now we're going to simplify, and the top is going to become an x minus 4 And the bottom is, okay, x minus 4 times radical x plus 5 plus 3. Now, not all the time, but a lot of the time, you'll see the numerator and denominator be same. Sometimes there might be a factor of 2 or 5 or some number. And really we get an equivalent equation of 1 over radical, ooh, made that radical a bit too big. X plus 5 plus 3. Now what we can do, we can use a direct substitution. So the limit as x approaches 4 of 1 over radical x plus 5 plus 3 is just like 1 over radical 4 plus 5 plus 3. We'll simplify that. 1 over radical 9 plus 3. 1 over 3 plus 3 equals 1/6. And we could double check on a graphing calculator, and the decimals should get really close to 0.1666 repeating. Alright, well, good luck on this section. This is it, and we will have a mid-chapter test after this. Good luck, guys.